Okay, this is the fourth video of the unit, the first video of lesson 2, but I don't think I'm going to break it up into lessons because we're going to do it all at once. This one is going to be about rotations. So we're going to start with the same first question. If we're rotating a shape around a point, a center, is the image or the copy, is it an isometry? I said in the last video that the dilation is the only one that's not, so this one will be yes because it stays the same size. Okay. Something that I don't want to glance by is that unless stated otherwise, rotations are always going to be counterclockwise. So if you see rotate and it doesn't say clockwise, assume that it is counterclockwise. The center of a regular polygon is the point that is equidistant from its vertices. The center and the vertices of a regular n-gon determine n-congruent triangles. You can use this fact to find rotation images of regular polygons. So that's just a fancy way of saying if you have a regular shape, you have a regular pentagon, and you want to figure out how far one point is from another, okay? You know, to go around in a complete circle, we need 360 degrees. Okay? How many triangles is it, or how many sides does this shape have? Is 5. That's how you figure out how many degrees it takes to get from one point to the next. Now, with lines, segments, it's a little different. Okay? We're going to rotate Tn 260 degrees, 16 degrees about x. Okay, but we want to figure out where we would end up. So for part A, we would end up at, so it's 72, so that means we're going counterclockwise because it doesn't say clockwise. Okay, so that means we're going this way. So we would end up at N. Now for Tn, okay, we're going 216 degrees. So we need to figure out how much ground that will cover. Well, that is one side of the triangle, okay? So what we really need to figure out is how many triangles over we're going to move. Well, we know that from one point to the next, it's 72, so we can take 216 and divide that by 72, and that will give us 3 over. So that would look like this would be 72, 144, and then we would finish at PA, 216. Okay. Rotate E around X, 144. Okay, so this is a little different. So we know that that's 2 movements. Right, because we got 144 total. We know that each movement is 72. That'd be 2 counterclockwise movements. So we'll start at E, 72, 144. So we'd end up at A. Now, finding an angle of rotation. Okay. Here we got a wheel. The center is C. So I'm going to mark it because it's not that clear on your paper. The center is C. And we're trying to figure out how can we get from Q to X. Okay. Now, if we think about this, we just need to figure out really how many triangles is that. So I'm going to draw them out, but I'm going to draw them straight. So we got 1, 2, 3, 4, 5, 6, 7. I think that should be 8. 1, 2, 3, 4, 5, 6, 7, 8. Or is that 9? Did I miss one? Or did I add one? Okay, so we got 9 triangles. Okay, so if we wanted to get from Q to X to figure out how much each one is, we would do 360, which is our total, divided by our 9 triangles, and we would get 40. So now the question is to move from Q to X, and we're going to go, remember it doesn't say clockwise, so we're going to go in a counterclockwise direction. How many jumps are we going to have to make? So we got 1, 2, 3, 4, 5, 6. So that's 40, 80, 120, 160, 200, 240. So that would be a 240 degrees counterclockwise. You don't have to say counterclockwise, but I just want to make sure I hammer that point home that if it doesn't say clockwise, it is counterclockwise. Okay. Now you can try to figure out how far it would be from M to Q. I mean, it'll be pretty easy because I've already did that part. Now let's look at the reasoning because that's kind of interesting. If I was to say, you could draw a diagram if you want, but if I was to say that we're rotating around point P, so that's the center, and we're going from A to B, and we're saying that that was a 50-degree rotation. Now it asks, how far would it be to go the other way from B to A? So we're assuming we're going to go in the same direction, right? It's going to be counterclockwise. So the way you find this out is if from A to B, if you think about a circle, rotate, you always rotate in a circle. If from A to B is 50 degrees, when you do B to A, you can't go back the same direction because we always got to go clockwise, counterclockwise. So you can go around this way to go to B to A, but we learned this in the circles unit, going around the other side, when we did arcs, you just do 360 minus what we got. So we know we'd have to go 310 degrees counterclockwise to go back around to A. Okay. I'm gonna do, how much time is this video? Okay, I'm gonna do a separate video for lines of symmetry. So that's the end of rotations.